So, hello everybody, good afternoon. I think we can all agree, and we heard it many times today, we live in challenging times and we all do business in very tough market conditions. So today I would like to ask you a question. So what if there is a solution that will help you to reduce your operational costs? And what if that exact solution will also help you to achieve your CO2 emissions targets? And on top of that, that solution will also give you a peace of mind because you know there is no risk for major shutdowns in your chemical operations. Well, that sounds a bit too good to be true, right? Well, my name is Georgios Vassiliadis and I'm a true optimist in this crazy world. And today you will learn about our all-new material, Sanicro 35. So who are we? We are Aleima, the former Sandvik Materials Technology, and we are an innovation-driven company, and we are materials technology leader in the stainless steel market. So what is this new innovation? I would like to explain that to you by using this diagram. It's a diagram with temperature over corrosion resistant and cost. So basically, when you look at chemical processes, you would start with a basic stainless steel, which is 304L, for example, so austenitic alloys. They are cost efficient, they can be used at high temperature, but they have the limitations in the performance of the material. If you need a better performance, you jump to the super austenitic, like alloy 28, for example, 1.4563, but they are more costly. Another alternative is the duplex family that Aleima and Sandvik also developed in the 1980s. They are cost efficient, but they have the limitations on the other hand at the temperature range. After that, if you have very tough conditions in your chemical processes, you have to immediately dump to very expensive nickel alloys with good performance, of course. But you can see in that diagram there is a gap, and that gap will be closed today with Sanicro 35. So we have identified that gap and we have closed that gap. We have a fully integrated production, which means from the melting to the bar production, production of hollows, so hot extrusion, and the cold flow is all done in-house. In order to get a better understanding about that alloy, we have to look at the chemistry, of course. And I'll keep it very short, I promise. There are three elements you have to take into consideration. If you look at the corrosion performance of an alloy, it's the so-called PRE value, the pitting resistance equivalent. And for Sanicro 35, it's 52. It's the highest, one of the highest in its class. And if you look into the formula, you see that there is chromium, of course. Every stainless steel needs chromium to create this protective oxide layer on the surface. So it's very high with 27. We also tried to look into the 6 moly family, like 904L, because that gives you seawater corrosion resistance or also resistance to many acids. So we targeted 6.5, and you need nitrogen, of course, to get a mechanical strength in the material. And all of that, you end up with a value of 52. If you look at the UNS number, this grade is classified as nickel-based alloy, but if you look at in the picture, it's an austenitic microstructure, and that has many benefits I will talk about in a minute. So coming to the properties, starting off with mechanical properties. So the minimum required yield strength for this one is 425. And if you look right next to Sanicro 35, you see the standard duplex grade. So they are pretty close, 425 to 485. As I mentioned, it's an austenitic microstructure, so compared to duplex, you have much better ductility, and this means you can form this material much better than duplex alloys. And another benefit is it has the very close strength as duplex, but it can be used at higher temperatures. So duplex is limited to 280 degrees. Sanicro 35, this year we have gotten the ASME approval to officially use it up to 550 degrees. Corrosion properties, super important in the chemical industry, of course. It's not easy to compare stainless steels with nickel-based alloys, so we went for the ASTM G150. It's an electrochemical test that is using the values that you see here, so 4.5 mol of magnesium chloride. You see here the major nickel alloys that are used in the chemical industry. So Sanicro 35 is outperforming host alloys like C4 and G3. but it has a very similar corrosion resistance as alloy 625. And alloy 625 is a widely used grade in the industry. All in all, this material gives you an as good corrosion resistance, but it is much cheaper. So just to give you a feeling, depending on the product form, you can save 20 to 30% compared to alloy 625. Of course, you can have the best material in the world if you cannot build any equipment, like heat exchangers, for example. So welding is a very big topic. And there are two options. You can weld the same material together, of course. We recommend alloy 59 as filler metal and argon and nitrogen as backing and shielding gas. So you see here some pictures. We have done two configurations, as you see on the drawing on the left. We used a tube sheet that is 50 millimeters thick. We recommend automatic TIG welding with a specific heat input. And the result was very good because you have the weld integrity, so the welds are perfectly fine, and by that you can guarantee corrosion resistance as well. This is one option. The second option is you have different materials. For example, Sonico 35 with super duplex. Same filler metal, same shielding gas and backing gas. And we did some mock-up welds that you see here. And we found out the base material, the HAZ, the heat affected zone, and also the weld metal show very good results. So what did we do? We wrote a preliminary welding procedure specification, PWPS, that can be used by fabricators like in Poland you have MESAP, for example, who are building heat exchangers for the chemical industry, and they can use that welding specification to produce heat exchangers with Sonico 35. What kind of products do we offer at Alema? So I already mentioned we have heat exchanger tubes. That's definitely the biggest portion. Moving on to hydraulic and instrumentation tubing, so small tubes with an outside diameter of 6 millimeters, for example. We also provide round bars. This year we will launch also cold hardened round bars that you need for bolts and nuts. Seamless pipe, of course, and again this year we will also launch fittings, so T's and elbows, for example. And last but not least, we can provide plates and sheets in that material. We use our partner Outokumpu, and they produce that grade under our license agreement. If you need a thicker plate than 50 mil, we work together with Rolf Kind company, also under our license agreement. I think that was enough theory, right? So let's jump into a real-life example. I brought one with me. It's an iron and steel plant in China for the wastewater treatment. So on the tube side, you have wastewater with chlorides and fluorides. And on the shell side, you have steam, and that steam heats up the wastewater to get ammonia sulfide. And this is how the tubes look like after only 1 year. So you see they use super duplex, heavily corroded. So they have shutdowns every year. They have to change the heat exchanger. So what did they do? And this is the vaporizer, the heat exchanger that you see here. And the tubes failed every year. So they tried our material, and on the picture on the right side, you see still the super duplex material that has heavily corroded, but the red circle, this is Sonico 35, which has shown a very good performance in that application. So what was the result? They changed the whole heat exchanger in 2022, and this heat exchanger is still up and running. So you can imagine how much money they saved by upgrading this heat exchanger and all the shutdowns, all the revamps. This easily ends up in a couple of million euros. Last but not least, I want to touch upon sustainability. At Alema, I know it's a big buzzword at the moment, but we don't just talk about it, we really do something about it. And we call it the cradle-to-gate approach. So as you can imagine, as a steel mill, we buy scrap, we produce our steel grades, then we produce the products for our customers, ship it to our customers, they use it, and after the end of the lifetime, we just buy it back like scrap, and the circle starts from scratch. So everything is calculated in-house based on this approach. All the calculations is from our own production data, including the yield loss. And we developed this by using the ISO standards. And of course, we got together with a third-party company because I mean, somebody has to control what we are doing and what we are calculating. So we use the IVL, the Swedish Environmental Research Institute, so that we can also have an independent party confirming our numbers. And I want to close my presentation with a very easy basic case study. If you look into round bars in this Sunicro 35 material, 84% is just coming from the scrap that we buy. This is the biggest part of our carbon footprint. 4% is only the steel melting itself. This is just a small number. And 12% is intermediate steps, like heating furnaces. And looking into the carbon footprint with absolute numbers, Sunicro 35 has a carbon footprint of 4.85. If you produce this wholly in Sweden, in our own production. If we take the very common alloy 625, it's even worse. So you have a worse carbon footprint, 7.25, and it's a much higher, a much more expensive material. And then if you buy 625 in Asia, it's even worse. You have a carbon footprint of 14.9. So I want to close my presentation by telling you that, coming back to my introduction, it is really our mission to help our customers achieve their targets, whether it's CO2 emissions, whether it's costs, whether it's just sleeping well at night because you know all the machines and equipments are running well, then Alema is your right partner. And as I said, I'm a true optimist. I think in these days, the whole supply chain has to work together, otherwise we will not be able to fight the challenges. So we have our own stand outside in the expo area. Please feel free to connect with us. My colleague Katarzyna Bombinska and myself will be happy to engage with you in further discussions. And by that, I want to end my presentation by saying dziękuję bardzo for listening, and I wish you a further good event. Thank you so much.